Next, I will explain very briefly about filters in the frequency domain. Let's assume we have a spectrum that looks like this. Here, if we are only interested in the frequency range below 1000 Hz, we can eliminate the frequency components in the range above that. It literally filters out sounds outside the frequency band of interest. The threshold frequency that defines this boundary is called the cutoff frequency. Commonly used filter types are as follows. First, there is a low-pass filter that only passes frequency components below the cutoff frequency. Conversely, there is a high-pass filter that only passes frequency components above the cutoff frequency. Also, there is a band-pass filter that leaves only a specific frequency range. And conversely, there is a band-stop filter that attenuates a specific frequency range. The frequency band that the filter passes through is called the pass band, and the band that it attenuates is called the stop band. This time, we will first listen to the original sound source and then listen to the sound with each filter applied and compare.
The waveform is the representation of change in amplitude over time of sound.
If you look at the spectrogram, you can visually see which band of sound has been filtered out.
The waveform is the representation of change in amplitude over time of sound.
When a low-pass filter is applied, you can see that the sound sounds somewhat muffled because only the low-frequency band of the human voice is left.
The waveform is the representation of change in amplitude over time of sound.
Conversely, when a high-pass filter is applied, only the high-frequency sound is left, so the sound sounds somewhat lighter.
The waveform is the representation of change in amplitude over time of sound.
If you apply a band-pass filter that filters out both low and high-frequency bands, only the corresponding frequency band will be emphasized and heard.
The waveform is the representation of change in amplitude over time of sound.
And if you apply a band-stop filter that attenuates only the area where the human voice exists, only the sound excluding the human voice band will remain. It is convenient to think of the equalizer we see in commonly used music player devices. You can think of the principle as almost the same. In this case, it not only plays the role of attenuating a specific frequency band, but also plays the role of emphasizing it. Let's briefly summarize what was explained in this chapter. First, we explained the spectrum, which allows you to visually check the frequency characteristics of a specific periodic signal. Since the sound we hear consists of signals with frequency components that change over time, we learned about a spectrogram, which visually expresses the changes in these frequency components over time. We also learned about the MEL spectrogram, which reflects human hearing characteristics in this spectrum. Finally, we briefly looked at the filter that attenuates or emphasizes a specific band in the frequency domain. Next time, we will discuss how to quantify the magnitude of sound energy. Let's find out what a decibel is, why we use negative numbers when talking about decibel values, and how to express the sounds we hear in decibels. Thank you.